So this is another video about the MathCON. So this is a grade 10 practice problems on the website. So if you look at the question, try first and see if you can get the answer and compare with my solution. That would be good. And the first problem we have is a number theory. So we are given two numbers like A and B. When you have a bar, okay, it says the meaning of that is the largest two-digit integer that you could get by multiplying product of the powers of A and B. So it's not obvious at first if you don't really like understand the statements when you don't see this explanation. So like it says like 3 and 7 is example, like there is a bar right here. When you look at the power of threes, like you could choose like any power of threes basically, but you want to get the largest two-digit number. And 3 to the 4th is 81, 7 to the 0 is 8, like 1. If you multiply, you got 81. And if you try some other combination, like 3 to the 3rd power and 7, you do get something that is not actually two digits, so you 27 times 7. If you choose to try like 3 squared and 7 to the 1st, that will be like 9 times 7, 63, which is smaller than that. So the 81 is the largest you could achieve by this guy, okay? And the same like for the second description, it says A and B. If the bar is at the bottom, that will mean the least three-digit number, okay? And the example is given. Based on this, what will be the difference of these two numbers? Since we have like 3 and 5 and the bar is at the bottom, we are looking for three-digit smallest number. So to do kind of like this problem, I will try writing power of 3s and 5s just to make sure I don't want to miss anything. So you can write the 0th power as well, but I'm gonna skip for now. And 27. And you're gonna find the three-digit numbers as the smallest number. If I try 3 to the 4th power, so you will get 81. And if I go with 5th power, it's gonna be itself already a three-digit, which we don't want to take it. And the 5 to the like first is 5, and 5 to the second is 25, which is already big. And when you multiply some different combination, including 0th power of this, you should be getting something smaller three-digit number. So look at the options. Like I can multiply 81 by 5, which is going to be already 400 something, which is a big value. If I choose 27 by 5, which looks like 135, and if I try 9 by like something like 25, that's already 225, which is big. So the smallest looks like 9, like 27 times 5, which is the 135. So 135 is the smallest three-digit number. And if I use the 2s and 3s, I know the power of 3s. I can list the power of 2s if I want it. And then I like to get the largest two-digit number. And if you look at the power of 2s, like I have 2 squared like 4, 2 cube is like 8, 2 4th is 16, 2 5th is like 32, 2 to the 6 is 96. I mean 64. I'm not sure why I say 96. 64. I've like, and if I multiply some power of 2s and some power of 3s, I should getting close to 100 because I like to get the largest two-digit number. So it looks like if I multiply this 3 by 32, which is 96, and then that is the largest I can get. And the difference between these two, like 4 more than 35, which is 39. So that would be my answer choice D. So the first question wasn't too challenging, but we don't want to take too long. I think this took a bit longer, but let's see the next question. Okay, this is the second question, and we have how many ways can two meetings be scheduled on different days between Monday, November 16th and Sunday, November 29th? Like, it's not too many days. Maybe it's good to list them. And then first day is Monday. Like we start with 16, and then you got 17, 18, like 19, 20, 21, 22, 23. I would say I would have missed like list this if I really have too many numbers, but in this case, it's not too many. So I'm gonna kind of list them, but we don't really need it if we know what we are gonna do, okay? So like if you list the 1 through 16, there's 16 numbers, 1 through 29, there is 29 numbers, but we are missing the first 15 out of 29. So if you subtract 14, I mean 15, because we are missing first 15. So we will be 14 numbers, which means we do have 14 numbers in this list. Some people may want to do 29 minus 16 plus 1, which is some people make like a formula like this, and that is also okay. But I like doing this approach. So we have 14 days, which is nice because that's just the 2 weeks period, right? And if that's the case, regardless of what day you start, you are going to end up getting every day twice, because just the twice of 7 is 14. So we have basically 10 weekdays. Okay. And then there will be 4 weekend. So if that was like more than like 14, or if the numbers like wasn't really multiple of 7, then we couldn't just do this way. But now we do have that, so which is a bit easier. And so what we want is at least one meeting should be on a weekday. So it could be both meetings or just one of them. So if I choose one of the meetings on a weekday, so it could be any of those 10 days because they are different day. So we have 10 options for the one of these meetings to be on a weekday. And the second meeting should be scheduled on a weekend. We have 4 options, so we can multiply this by 4. So in this case, one meeting is on a weekday, the second meeting is on a weekend. But this is one case, or we can just schedule both meetings on a weekend, right? Like it's, I mean, weekdays. So we have 10 of these days, and then I can choose 2 days, which is 10 choose 2 ways to decide what 2 days I like to schedule. Like I wouldn't do 10 times 9, because when I do that way, I say let's schedule on Monday and Tuesday and Monday, like assuming they are different, but that's the same thing. So which is why we don't care the order. So which is why we use combination instead. So that will be 40. And 10 choose 2 is like 10 ways to choose the first day, 9 ways to choose the second day. But choosing 2 days can be done 2 factorial ways, which will give us the same 2 days. It doesn't matter. So we should fix that over counting by dividing by 2 factorial. That's 45 plus 40, which is 85. So that's the choice D as well. Okay, so that was basics of combination. I hope that was clear. So let's look at the next problem. So this is the number 3. So we have geometry. So regular polygon is surrounded by a set of regular hexagons like this one and some squares, which is given. They have a common side, which is this one. And what is the number of sides of the regular polygon, which we don't see the whole picture. And the first thing that we probably need to remember is the n minus 2 times 180 is the sum of the interior angle for any polygon. And if you don't know why n minus 2, you can take a look at that. And if this is a regular polygon, we can divide this by n to get one of the interior angles. Okay, so this is going to be one of the interior angle for any polygon. So like, why do I need? Because I do need to know the interior angle. So I can use this expression to find the number of sides, and is the number of sides. And this is a regular hexagon. And if you do remember, you can just tell this is 120. If you don't, you can just still use this one. So if this is like 6 side, so 6 minus 2 times 180 divided by 6, right? So that will give us like 30, and this is 4, so that is 120. So one interior angle is 120. And this is a square, so which is 90. If you add those, that's 210. If you subtract from 360, so you will get this interior to be 150. So then we know that this is equal to 150. Okay, and what we want to find is the n. So we can multiply both sides by n. So you will get 150 n equals n minus 2 times 180. And I don't want to multiply before I do simplification. So I'm going to cancel these zeros by dividing by 10. I can even divide by 3. So that will be 5n. And if I divide by 3, that's 6 times n minus 2, which is 6n minus 12. And if you subtract 5n from both sides, so we will get n on the left. If you add 12 to both sides, so you get n as our number of sides, which is 12. And this is one way we can try this problem. The second way, as soon as we have the 120, which is obvious figure, so most people do remember that anyway, and 90 degrees for this angle, that's 210, and that's 150. as soon as we know the interior angle of the polygon is 150, and when you extend this, like you do get exterior angle, like which you can just get as 30 degrees for the exterior, because the interior 150 plus exterior is 180. Where some of the exterior angle in any polygon is always 360 regardless of the size. If you divide 360 by the one exterior, because this is regular, so you will actually get the number of sides, because the number of vertices is going to be same as the number of like sides. Without really using the this some people say formula, we can just do this as well, which is way easier than the first approach. So let's look at the next problem. So here's the number 4. So we have a positive real numbers, a and b are the solution of this quadratic. And based on this, what would be a plus b? Like this is a question where we can use the VX relation if you are aware of that relation. And if you don't, we may just use slight differently. Like when you are given like a quadratic, let's say x minus 2 and x plus 5 equals 0, right? And if I ask you this to tell me the solution, you would just say this has to be 0, which makes x equals 2. This has to be 0, which makes x equals -5. So these are the solution. Like if you know the solution, which is 2 and -5, we can just use the solution to write the equation as factor form. So x minus the solution, x minus the solution. So x minus -5 is just x plus 5. So you can just get that. So the question was telling us the solutions are a and b, which means my quadratic can be written x minus a solution, which is a, times x minus the second solution, which is b. But this is equal to this guy somehow, but when you expand them, you got x times x, which is x squared, but there is 2a right here. So to get rid of that like problem, so I'm gonna divide this equation by that number, which is 2a, and I will divide by 2a. If I divide this by 2a, these 2a's will cancel because I know a is real number, and so we can divide by like a if unless this is a 0, but we are told that's positive, so we are safe. So if I divide by 2a, so we'll get x squared and then minus 5b over 2a, and then there is an x, and plus 8b over 2a, which is 4b over a. Okay, I'm just using this because I don't like just using the VS for those who doesn't really know about it, but you can just go with that immediately. And if I expand the left side, so you will get the x squared. So then x times b is bx, but that's minus bx. And then this time this will be minus ax. And then this time this will be just ab. And this is equal to x squared minus 5b over 2ax and plus 4b over a. Okay, so if I clean this left side a bit, so we have only x terms, so maybe I can subtract x terms from both sides, but I don't want to do that because we're going to make them equal to. And the middle two terms can be combined, so minus b and minus ax, so it can be written as minus b plus ax and plus ab equals x squared minus 5b over 2a. And then there is x right here plus 4b over a. So now, as soon as we have this, we know this is a polynomial. This is also a polynomial. So then the degree terms that has the equal value, the coefficient should be same. So x squared has a coefficient of 1, x squared has a coefficient of 1. They has to be same, which is, and the coefficient of the x term, which is this number, has to be same as this number. So since both is negative, so we can just say b plus a equals 5b over 2a. And similarly, the constant term, which is ab, and this guy should be same as well. So the ab has to be 4b over a. So this is easier to solve because since we know a and b are positive real solutions, so we can divide both sides by b. So this was a times b. So the b's will cancel when you divide by b. So 4 over a equals a. So if I multiply both sides by a, so you will get a squared equals 4. Then a could be 2 or -2, but we should take the positive since we are told that's positive. A is 2. And if a is 2, I can plug it right here. So then that will give us b plus, let's do that. So the b plus 2 equals 5b over 2 times 2, which is 4. And if you multiply both sides by 4, so you will get 4b plus 8 equals 5b, and subtract 4b from both sides. B will be 8, so a is 2. So if you add them, so you get 10 for this sum. So this is one way we can do it if you don't know the VS relation. But if you do, then this is going to be way better to use the VS instead of this approach. So the VS was telling us the sum of this solution is the minus b over a. So the sum of the two numbers, like a and b, are the solution. And then b is just the negative, like the term before the x term, which is negative b. So you take the negative of that number, so negative of negative b, over the coefficient of the square term, which is 2a. And that is gonna give us immediately sum of the solution. And the product of the solution is the constant term, which is 8b, divided by coefficient of the square term, which is 2a. And if you just remember that, that's two equations that we could get immediately, which we already have, like the product right here and the sum right here. So without really doing these middle steps, we could just receive this immediately by using the VS relation. The rest is the same as this approach. So we are done with the problem. So I hope that was clear. I'll see you in the next video.